Hopefully y'all are doing well. So today what we're going to be doing is continuing our notes on solutions, specifically math of solutions. Okay. Now for this, you do need to make sure you've got your notes, something to write with. You need a periodic table, and you will also be needing your calculator. So go grab those four things. Pause your video if you need to go grab them, but we're going to go ahead and get started on our solution notes. All right. So for this last unit, last time we talked, what we talked about was what a solution was, and we talked about some factors that affect it. Today, we're going to be talking about concentration. And a lot of times when we're referring to solutions, we refer to the concentration because guess what? Concentration has a big effect on how it reacts with everything else around it, how quickly it reacts, and those kind of things, right? So let's look at this and let's do some math to figure out what the different concentrations are, and we'll talk about some other things as well. Okay, so starting off, concentration. Our word for concentration in solutions is molarity. And so for molarity, remember that molarity is moles of solute per liter of solution, specifically 1 liter of the solution. So we're looking at the solute in comparison to the whole thing, all of the solution. All right. And so keep that in mind. It is going to be everything with the moles of solute per the entire solution. Okay. Now, here is our formula. Molarity is moles of solute divided by liters of solution. Okay. And we can manipulate this equation if we're solving for one of the other variables, but this is the solution we have for molarity. Now, this should be on your periodic table that we gave y'all at the beginning of the year. So make sure that you've got that because that will be an additional resource that you can use when you're taking your AP exam. All right. Okay. So how much solute in grams is needed to make each of the following solutions? So what we're going to do is we're going to work through this. I'm actually going to do this first one with you, and I'm going to solve it in 2 different ways. And then I'm going to let y'all work on the next 2 problems and we'll talk about them. Okay. So first off, how do I do this? Well, there's 2 ways that you can do this. The first way is to kind of get in and separate all the little pieces and solve with all the little pieces in your molarity equation. So plug everything back in after you solve for that. So let's do that. So first off, it says 250 milliliters of a 0.00100 molarity Na2SO4. Okay, first off, remember our formula or our equation for molarity is molarity equals moles of solute over liters of solution. Okay, well, they're asking specifically how much solute in grams. That's what we're looking for. So how much solute in grams? Well, that means we're going to have to solve for moles, right? And then convert into grams later. Okay, so we do need to remember that. So for that, though, to do that, we need to take our molarity equation and manipulate it because we're going to start off by solving for moles. So we're going to rearrange this. Remember, to get something off of that's being divided on one side, we're going to multiply. So we're going to multiply both sides by that liter. That's going to cancel it out over here. So our formula is moles equals molarity times the liters of the solution. Okay, so now we've manipulated our equation. So now let's go ahead and start to plug things in. Okay, now first off, we need to remember that molarity is moles of solute per liter of solution. That's milliliters. So before we can do anything else, we're going to have to actually convert that milliliters out of milliliters and into liters. So let's do that. So 250 milliliters, using our dimensional analysis, we go from milliliters into liters using our conversion factors. 1 liter is 1,000 milliliters. Plug that into our calculator. If we need to, we're going to get 0.250 liters for that volume. All right. Now we can plug that into our formula. So I know that moles equals 0.250 times the molarity, which we know is 0.00100. Okay? I plug that into my calculator, and what I'm going to find is the moles equal 2.5 times 10 to the negative fourth. Okay? So that would be how many moles I have. But the question asks for grams. So now I need to take this number, and I go 2.5 times 10 to the negative fourth moles. And I have to convert that moles into grams. We do that using our molar mass. Now, we're asked specifically for Na2SO4. So I take my sodium, which has a mass of 22.99, plus my sulfur, which has a mass of 32.06, plus the oxygen, which has a mass of 16. I multiply them by their subscripts. And then what I'm going to find is that I have a total mass of 142.04 grams per 1 mole. I'm going to take that, I'm going to plug that into my calculator, and I'm going to find I have 0.036 grams of Na2SO4. All right, so then this would end up being my answer. All right, now for me, I find that confusing because there's a lot of different steps that I've thrown everything in, and so for me, I struggle with that. So instead, I'm going to show you another way that you can do this. And do this in a different color. Let's go with red. And this is just going to use dimensional analysis in its entirety. So we're just going to use dimensional analysis to solve the entire problem with one dimensional analysis problem. Okay? So what we're going to do is we're going to start with our volume. Now, why would we start with volume? Well, I'm given two different things. I am given a volume, and I'm also given a conversion factor. I'm told that I have 0.00100 molarity. Now remember, molarity is moles of solute over liters of solution. So I have 0.00100 moles per 1 liter. So it's a conversion factor I can use. And that'll get me into moles, and then I know I can use moles to convert into grams. Okay? So that's what we're going to do. We're going to start with our 250 milliliters. Now, milliliters was not what I was looking for, so I drop it low. And here, I'm going to actually need to go to liters. Why? Because liters is what our molarity is actually in. So we're going to go from milliliters into liters. 1 liter is 1,000 milliliters. Now, done with that, I've converted it into liters, but I'm not all the way to where I need to be. So I ask myself, is liters what I'm looking for? If no, drop it low. So no, it's not. I'm trying to go from liters into grams. I don't know that, but I do know how to go from liters into moles. I'm going to use my concentration. I know that I have 0.00100 moles for every 1 liter. Okay, well now I've gotten rid of my liters and now I'm into moles. But I'm not solving for moles, I'm solving for grams. So now I drop down my moles because it is not what I'm looking for. And I go from moles into grams using my molar mass. I have 142.04 grams for every 1 mole. Is grams what I'm looking for? Yes. So now it's time to solve. Plug everything to in the calculator, and what I'm going to find is I have 0.036 grams of Na2SO4. Now for me, I find that a lot easier. So I'm actually going to, on the next two problems, when we solve them, I'm going to solve them using that method there. But you can solve whatever works. You can solve it in whatever way works for you. All right. So what I want you to do is to pause your video, go ahead and solve question 2, and then we'll talk it through. All right. So pause your video, solve question 2, and then we'll talk it out. All right. All right, so hopefully you paused your video, but here is the work that we would have done. First off, we converted 100 milliliters into liters, and what we found, we saw for that. Then we went from liters into moles, and then we went from moles into grams. And then when we did that, we plugged all our numbers into the calculator, and we should have ended up with 2.65 grams of Na2CO3. All right, so Y'all can pause your video and solve for the next one. I'm just going to go ahead and work out the problem and then show you the problem real quick, and then we're going to go ahead and move on. All right, so pause your video if you need to. All right, so there is our answer for that. Now, another thing that they could do is actually give you a word equation. So it says, what is the molarity of a solution prepared by dissolving 17.1 grams of ordinary sugar in enough water to make 0.500 liters of solution? So I want y'all to pause your video, work the problem, and then I will go over it real quick with you. All right? All right, so here would be what you did to solve the problem. So first off, we needed to take that 17.1 grams of ordinary sugar and convert that into moles. What we find is we have 0.0500 moles of that C12H22O11. After that, we use our molarity equation. So our molarity formula is molarity equals moles of solute over liters of solution. So my molarity equals 0.0500 moles divided by the volume they give us, which is 0.500 liters. And when we do that, what we should find is that our molarity, our concentration, equals 0.100 molarity of C12H22O11. So this would be our final answer. All right. So there is that. So we are going to keep on moving on. First off, we do need to keep in mind that when we are making a solution, when we go through making a solution, we do need to use a volumetric flask. That is what they're designed for. That is what we should use them for. And so we got to keep that in mind when we solve these, when we actually make solutions. Okay, so use a volumetric flask, and we'll talk about how to actually prepare that solution. So how to prepare a solution. If I want to make 1 liter of a 2 molar solution of potassium nitrate, here's what I need to do. The very first thing that I need to do is calculate how many grams is contained in 2 moles of the potassium nitrate. Because remember, we've got moles divided by liters, and that would be our concentration, right? And we know it's out of 1 liter, so then that's what we're going to use for our actual equation. So I have 2 moles of that potassium nitrate. I convert that into grams. What I'm going to do then is I'm going to take that mass, and then I'm actually going to use a weigh boat and measure that exact mass on a balance. Okay? So whatever the mass is, I'm going to measure that mass. Then I'm going to take my weigh boat, and I'm actually going to, using a funnel, pour that solid into my volumetric flask. Okay? So I put it into the volumetric flask, specifically a 1 liter volumetric flask. We should always use a volumetric flask that is the size that we are looking for. So 1 liter. Next, I'm going to take that and I'm going to fill it about 2/3 full with probably a distilled water. Distilled or deionized water would work. So fill it with distilled water, and then I'm going to mix it up. I'm going to mix it up. And what that's going to do is it's going to cause that to dissolve. Okay. Once I've done that, then, and it's completely dissolved, then I'm going to take my distilled water and fill it up exactly to the line that's on the neck of the volumetric flask. If I go above or below that line, it is not the solution that I was trying to make. Okay. And so we have to be very, very careful when we're making that. All right. Now, you will not be adding 1 liter of water to that solution. So that is a common misconception, is when it says how to prepare 1 liter of that, you're like, okay, well, I'm just going to add 1 liter of the water to this. No, you cannot do that. Why? Because it's not asking you for 1 liter of water. It's asking you for a total of 1 liter of that solution. So keep that in mind. If you add 1 liter of water, you are going to be adding the wrong amount of water. So we always use a volumetric flask because that's what's going to give us that exact volume that we need to have. Okay? All right. Next thing we need to talk about is a mole fraction. Now, a mole fraction is the ratio of moles of a given component in the total amount of moles in that solution. Now, one thing that I will say is that you need to remember, I forgot how to spell remember for a second there. You need to remember that 1.00 milliliters of water is equal to 1 gram of water. Okay, so keep that in mind when you're working these problems. 1 milliliter equals 1 gram of water. Okay, all right, so my question here is hydrogen sulfide gas has a solubility of 0.385 grams of per 100 milliliters of water at 20 degrees Celsius and 1 atmosphere. Calculate the mole fractions of both the solute and the solvent in a saturated solution of hydrogen sulfide in water under these conditions. Okay, now remember our mole fraction equation is I'm going to take the mole fraction of whatever element I've got. So I'm going to be looking for H2S. I'm also going to be looking for H2O. So I'm looking for the mole fraction of both of those things. Now for that, I need to know the total number of moles that I have, which means I need to take both of these values that I have and convert them into moles to see how many moles of each substance I have. So the first one I have is I have 0.385 grams of the hydrogen sulfide gas. So 0.385 grams of hydrogen sulfide, H2S. And I'm actually going to convert that into moles. We're going to do that using our molar mass. We know that grams per mole. So we're going to find the molar mass of hydrogen sulfide, 2 hydrogens at 1.101 each, 1 sulfur at 32.06. What we're going to find is that we have a molar mass of 34.08 grams per 1 mole. I plug that into my calculator, and I am going to get 0.0113 moles of H2S. Okay, well now I have how many moles of H2S I have, but I need to find out how much water I have. So I have 100 milliliters of water. So we are going to go from milliliters of water into grams of water. And we have 1.00 grams for every 1 mole. Well, now we're in grams, so we're going to go from grams of H2O into moles of H2O using our molar mass. 18.02 would be the molar mass of water. Plug that into our calculator, and we find we have 5.55 moles of H2O. All right. Now, what we need to do is we need to take those and add them together. Why? Because that's going to give us the total number of moles that we have. So 5.55 plus 0.0113, and we're essentially going to get 5.56 moles for our solution. Okay, now we need to take that, and now we can solve for our mole fraction. So I'm going to come back over here because I've got a little bit more room. So I have for the mole fraction for H2S, we're going to take 0.0113 divided by my total amount, which was 5.56, and that's going to give us 0.00203. Okay, so that's the mole fraction for H2S. And then we are going to do the same thing with H2O. So 5.55 divided by 5.56, and we're going to get 0.998 as our answer. So that would be how we solve for our mole fraction. So I want y'all to come down and solve this easier problem for solving for mole fractions. All right, so pause your video, solve the problem, we'll talk about it. Go ahead. Okay, so let's take a look at this. So the first thing that you needed to do was to add up your moles. Why? Because that gives us the total mole volume for the total number of moles in the entire solution. Wow, struggled there a little bit. So it is the total number of moles in our solution there. Then we're going to take our individual number of moles, so the moles of sodium chloride divided by that total number of moles, we're going to get 0.19. We do the same thing with water, 5.0 divided by 6.2, we get 0.81. That would be our mole fraction. All right, one last thing that we need to cover, and then we are done with this solutions math. So, last thing to talk about is dilutions. So dilutions would be us taking a solution that's already made and diluting it down to a lesser concentration. Okay, so to dilute means that we're going to be adding more solvent without the addition of solute. If we add more solute, we're not going to be changing that overall concentration. So we do need to keep that in mind. Now, here is our formula for dilutions. M1V1 equals M2V2. Now, here's something to note. This is actually something that's different from the molarity equation. The molarity equation, if you remember, you always had to be in liters. That doesn't happen with dilutions. So my volume could technically be in milliliters, and that is okay. But if it is in milliliters, you need to make sure that both of your volumes are the same. So if one's in milliliters and the other is in liters, you're going to have to convert one to the other. All right? So we need to keep that in mind. We need to make sure that we are consistent with whatever unit we choose for our volume here. All right? Okay. So here is a question. What volume of 16 molar sulfuric acid must be used to prepare 1.5 liters of a 0.10 molar sulfuric acid, H2SO4? Okay, so my formula is molarity 1 volume 1 equals molarity 2 volume 2. M1V1 equals M2V2. And I am solving specifically for volume 1. So I just plug in my numbers and I solve. So I have 16 molar solution times my volume 1 equals 1.5 liter times 0.10 molarity. I'm going to divide both sides by 16 to get that off of that side. And what we're going to find is that our volume 1 equals 0.0094 liters of H2SO4. So to make that solution, I need to add this small amount of H2SO4 to that small amount of H2SO4, and that would prepare 1.5 liters of that solution. All right? Okay, so what I want y'all to do is to solve this next problem, and then we will work it together, and then we will be done. All right? So pause your video, solve the problem, and then we will get to it. All right, so here is our work for this. So we did have 17.8 molar stock sulfuric acid solution. Now here's a hint. Stock solution means it is your beginning solution. You always start with that stock solution, okay? So I have 17.8 molar stock solution, and I'm trying to make 2 liters of a 0.2 molar solution by diluting the original concentrated stock solution. So I have 17.8 times my volume 1, which is what I'm looking for, equals 0.200 times 2. Divide both sides by 17.8, and we will find that our volume needed would be 0.0225 liters of H2SO4. All right, y'all, so that is it for your solutions math. As always, let us know if you have any questions and reach out to us if you need us. But otherwise, y'all have a great rest of the day. Bye, y'all.